These are your guided notes for lesson 5.6, direct variation. Your I can statement for this lesson. I can use graphs and equations to show direct variation. Your key vocabulary is, of course, direct variation. Direct variation is a relationship between two variables where one is a constant multiple of the other. If one variable changes, the other changes in proportion to the first, and that's the key word, is in proportion to the first. So we can have a relationship where if one variable changes, the other also changes, but the key is that they are changing in proportion. So your direct variation equation is y equals kx. Y equals kx. And you can see the labeling here. K is a constant. It's going to be a whole number, an integer, a fraction, and it will be the constant. X is a variable, y is a variable. X is your input. We've talked about this in class. And y is your output. So as the x changes, your input, the y is also going to change, your output, and they're going to change in proportion to one another. And the only exception in this equation is that k cannot equal 0. We'll discuss that in class. Constant of proportionality in y equals kx. K is your constant of proportionality in y equals kx. When the equation is in that form, we'll discuss how to get equations into that form. And not all equations can be put into that form. The graph of y equals kx is a line with a slope of k that passes through the origin. So two quantities that show direct variation are in a proportional relationship. So something you may have missed there. The graph of y equals kx is a line with a slope of k. So k is the same thing as slope that we've been talking about this whole chapter. So k is your constant. Okay, you have a constant of proportionality, COP for short, constant of proportionality, and that's what k is. And k is the same thing as slope, which is your change in y over your change in x. So that's key as far as connecting the dots from what we've discussed in this chapter and what's new coming up. So let's take a look at a couple of problems here. If we look at the directions, identify direct variation by graphing, tell whether x and y show direct variation, explain your reasoning. So it's the same as proportionality. So it's telling us that they have to be proportional to one another. And if you remember, with that, we talked about lines and what they need to look like to be proportional. So if I have a line like this, we know that that's not proportional. It is straight, but it's not crossing through the origin. If we have a line that looks like this, that is not proportional as well because it crosses through the origin, but it's not straight. So proportionality would look like that, crossing through the origin and a straight line. So it's the same thing with our direct variation. So this red line here does not have direct variation because it does not cross through the origin. This red line here does not have direct variation because it's not straight. The blue line does have direct variation because it crosses through the origin and it's a straight line. So again, all same rules that we've been discussing in this chapter. It all connects. Now they're asking us to plot these points and draw a line and explain whether this is direct variation or not. So x is 1, y is negative 2. So from the origin, write 1 down 2. 2, 0, write 2, and then don't go up or down at all. 3, 2, so write 3, up 2. And 4, 4, write 4, up 4. So use a straight edge. I can't use it on this program, but you should use a straight edge to connect your dots and extend it all the way through the graph and put an arrow on the end. Now we want to answer that question. Does that graph show direct variation? The answer would be no. And then you need to add to that, does not cross through the origin. Tough to write with these pens. Okay, so you graph it, and just like we've done in previous lessons where we were asked if the relationship of the x and y's are proportional, it's the same thing. They're asking, do they have direct variation? Same criteria have to be met by the line. Does it cross through the origin? Is it a straight line? All right, we look at the second one, B, graph 0, 0, graph 2, 2, right 2, up 2, 4, 4 from the origin, right 4, up 4, 6, 6, right 6, up 6. Again, use a straight edge, connect your dots, extend it through the graph, put an arrow on the end. Our answer here clearly is yes, and you need to write on your paper that it crosses through the origin and it's a straight line. That's your explaining. Okay, I want you to explain your reasoning. So it's a straight line and crosses through the origin. So yes, there's direct variation. So now we're looking at our equations being written into direct variation form here, the y equals kx. All right, so y is a number, k is a number, x is a number. It needs to be written in that format. Can't have anything more, anything less. And we actually can't have less. We'll talk about that in class. So again, thinking back to previous chapters, so just solving equations, you want to get y by itself. So a is done for you, but we'll look at the steps to make that happen. Y plus 1 equals 2x. So right now it is not in y equals kx form. The y is not all by itself. So we want to get y all by itself. So for that to happen, we need to get rid of plus 1. So we subtract 1 from both sides, and we would get y equals 2x minus 1. We can't subtract 2x and 1 because they're not like terms. So the y is now by itself. There's nothing we can do to the right side to simplify it. So does this look like this, y equals kx? The answer to that question is no, because of the minus 1 at the end. So in the y equals kx, we can't have any plus or minus after it. So 2 is your k, x is your x. We can't have plus something or minus something after it. So this equation, when we got y by itself, is not in direct variation equation form. So same thing with b. We have 1/2 y equals x. We want to get y by itself. One of the ways we can do that, we can either divide by a half or we can multiply by 2. So I multiply by 2. The times 2 and times a half cancel each other. So y is by itself, and on the other side I would get 2x. So I get y equals 2x. Is that in this format? The answer to that question is yes. Y equals 2x. And so 2 is your k, your constant of proportionality. So now we get a table. They're giving us area in square feet, time in minutes. It's telling us the time that a robotic vacuum cleans in X minutes. Graph the data and tell whether X and Y are directly proportional. So it's already graphed for you. They have graphed all of these ordered pairs over here. We can see clearly that the line passes through the origin, and it's a straight line. So it says, does the line cross through the origin? Our answer is yes. Are they directly proportional? Our answer is yes. Again, crosses through the origin, and it's a straight line. Now there are questions on this graph that I'll flip back to. It says to write an equation that represents the line. It takes us through the steps. So first, choose any 2 points to find the slope of the line. So I'm going to choose 1, 16 and 2, 32, just avoiding fractions. So I'm going to choose 1, 16 and 2, 32. Again, we want to find the slope, so it's the change in y over the change in x. So I'm going to do 32 minus 16 on the top, and I'm going to do 2 minus 1 on the bottom, and I'm going to get 16 over 1. So that's my slope. And if you remember, if I still have it up there, from way back here we said that k and slope are the exact same thing. So when you found the slope is 16, you have also found that k equals 16. Second, write an equation that represents the line. Y would stay y equals We just found that the slope is 16, and slope and k are the same thing, so that would be 16, and then x stays x. So our direct variation equation is y equals 16x. Now it says use the equation to find the area that was cleaned in 10 minutes. So remember, minutes is your x, so we just replace x with 10. So we have y equals 16 times 10, and we get y equals 160. So our answer is 160 square feet. That's how much it would be able to clean in 10 minutes. So now you have you try on your own. We'll go over these notes in class and clean things up.